would not be good.
Yeah. All right. Okay, another student. I'll do it. Yeah, this admit sometimes that doesn't work. Let me do it
Well,
one more.
I've been admitting them.
Oh,
And I went out
okay.
there.
I'd rather not. I'd rather if you did it.
Shit,
I'm-
power.
Yeah.
I don't really want to pay attention to that.
Yeah, then we will be in trouble.
Yeah. Okay. All right. So let me see. Okay. So the setup is almost okay.
So you see that person in the waiting room, you can't admit them?
Sometimes.
Oh, there you go. Okay.
Yeah. If I only see one there, sometimes I have this kind of difficulty.
Okay.
I need sometimes click once, sometimes click twice. But
Okay.
if I have more than one, they have like admit all, then I don't have problem. So I think their interface has some issue.
Okay.
Yeah. Yeah. All right. Okay. Let me see. Oh, okay. So how's your other courses in this term?
Pretty good. My Six Sigma class ends in 2 weeks, and then my the engineering econ class runs till second week of June, and my MBAs I have up at the pharmaceutical company that runs till the second week of June. So doing okay.
That's really keep you busy.
I have enough to do, but I'm worried about the fall because none of my undergraduate stuff is set up for online.
Yeah, yeah, that's the issue. That's the issue. So looks like a term we will not do online, right? We will
Yeah.
kind of go to the new normal, right? Yeah.
Oh, we got Chris Brown. Okay.
Oh, yeah. He's online, right? He's online. Okay. Okay, I guess we got a lot of students. I guess we can start. How do you think, Wally?
Yeah, I'm good. Let's see. It's
All right.
12:01.
Yeah.
So once I start talking, I'm gonna switch off my camera.
Yeah, me too. Yeah, probably just to make sure. No, you can still keep your video on, right? Your camera on. I need to probably stop that just to make sure everything is smooth. Let me see. Okay, let me get started. Okay, hi everyone. So welcome to the seminar. As you may remember, the Excel sheet I showed to all of you. So today is the second to the last, right? Seminar we will have. So after Professor Tony gave the seminar in this week. So next week we will have a student from Sierra Cube to give their talks. So we will finalize the schedule. The detailed students, the topics, everything, probably in a day or two. And after that, as usual, we will send out the flyers out. Okay, so as I said, next week will be the last one. So that's pretty much the arrangement of the seminar in this term. So today it is our great pleasure to have Professor Walter Tarney to give us a second talk. So I really appreciate his help, in this difficult time. So today what he brought to us is what do MFEs need to know about the digital scaling in a manufacturing supply chain. So I believe not just MFE should know this, right? So this also applies to the
I
MTE
would hope
student.
so.
Yeah, yeah. All right. Okay. So it's all yours. I start to do the recording.
Okay, very good. Well, thanks, Mike. I appreciate it. And so let's see, we have a poll running here. I don't know what that.
Yeah. So the poll is only for students to.
I know, but it shows up in the middle of my screen.
Yeah. Okay.
Okay, so here we go. Hi, everyone. Thanks for joining me for my talk today on what do manufacturing engineers need to know about digital scaling in a manufacturing supply chain. And so here's the abstract for today's talk. And much of the material shown in this presentation came from the global consulting firm McKinsey & Company, and also the World Economic Forum and the Wall Street Journal, and there's some academic publications. I have a personal rigorous reading schedule of newspapers, trade magazines, and academic papers in order to stay current with both industry and academia. And I recommend that you do that as well. So this talk has three main parts. The first provides a lot of current thinking on the best manufacturing companies in the world and why they are some of the best manufacturing companies in the world. And the second part is about your ability to recognize opportunity for digital scaling and manufacturing. And the third part focuses on some skills that you can learn at WPI to support your career. So over the past couple of months, on the front page of the Wall Street Journal, there's been many stories about COVID-19's impact on the world, and frequently manufacturing companies are highlighted. Very few manufacturing companies have escaped a significant downturn unless they were directly involved in the healthcare supply chain. So we don't know who the winners and losers are going to be in the future, but many companies have had to change their product offerings and manufacturing processes to respond to a drop in demand in one part of their business and new opportunities arising in other parts. And one interesting area of manufacturing is accelerating production of drones for routine residential delivery of restaurant food and small parcels. So the COVID virus has been the best sales force that the drone manufacturing industry could ever have hoped for. And they have sales that are beyond whatever they could have imagined probably just 4 or 5 months ago. So the main idea in this talk resulted from articles on manufacturing lighthouses, and specifically global digital manufacturing lighthouses. Digital manufacturing lighthouses uses fourth industrial revolution technology deployed across substantial elements of their enterprise. And the digital lighthouse uses the Internet of Things and workforce reskilling and upskilling to increase manufacturing capacity and quality by large increments. Many manufacturing companies would be happy to grow at 2 or 3 or 4% a year. Digital manufacturing lighthouses attempt to increase sales and drive productivity gains in the order of 10 or 20 or 30% a year. So this white paper was produced by the World Economic Forum in January of this year, focused on 44 global digital manufacturing lighthouses. And this particular paper focused on the potential productivity increases in Western Europe as compared with the rest of the world. But all these conclusions can be extrapolated to any geographic area or country. This graphic shows 2 different types of lighthouses, pretty evenly balanced between end-to-end connected value chain lighthouses, which integrate their supplier base, and the other type of manufacturing lighthouse that attempts to make all the productivity gains in-house rather than going out and integrating with the supply chain. And it's not an either or option there. It just depends on circumstances and perspective of the company. So these are the 44 companies, and I've given links to all of this information throughout this presentation. So I highly recommend you go find these papers and pull them down and look through them at your leisure to get some more detail, because there's some really fascinating things in there. So what might be of interest to manufacturing engineers is the results of becoming a digital manufacturing lighthouse. It shows that productivity is in the output of the factory, or internal productivity, or overall equipment effectiveness, and the cost of quality has been reduced substantially, and they get operational and financial gains for these companies. And that, so if you look at all of these different capabilities that you know, being able to drive bottom line because they're more efficient internally is really the biggest gain that you get from becoming digitally enabled, or more digitally enabled. So I have a lot of examples that I pulled out of the paper that I thought were pretty interesting and applied directly to manufacturing engineering folks. And so the paper has a lot of detail on a company by company basis. And I just have a few slides of interest to MFEs. The study shows the before and after thinking at each of these global manufacturing leaders. Worker empowerment is evident in many organizations where the product and process innovations are driven from within the company by the people that are responsible for the process. So this thinking fits very much with lean process improvement, where top-down management command and control generally leaves the operation sub-optimized. The people that are closest to the process, which could be you as a manufacturing engineering person after graduation, are the experts when they're given a voice in company operations, and the results that you can achieve can really be impressive. Taking one example from this slide, I own innovation in my production line. We all come up with ideas. So who exactly are they referring to? Well, they're referring to you, the manufacturing engineer, as well as the other participants in the manufacturing process, to drive improvement from the bottom up. This slide shows another group of well-known companies across a cross-functional team that facilitates change regarding companies' digital processes. Production line problem solving is pushed down to the lower levels of the manufacturing team so that the data produced on the production line can be acted upon directly without much upper level management involvement. And so these less layers of management that you need to resolve a problem produces higher productivity gains. This last group of companies reinforces the real-time use of data from manufacturing to do root cause analysis and make modifications to the production process without upper level management involved with. None of this would be possible without the gathering of data from the manufacturing process itself and integrating it with customer requirements and customer demand data. So another area where digital scaling has an impact on manufacturing is producing a digital production optimization. Manufacturing engineers that may or may not be located near the production system are able to interact with a digital twin of a part that, or an assembly or a final product that's undergoing processing, and you're able to make adjustments and transmit that to the manufacturing floor in real time. The other highlight in the slide shows the connection of machine level data with enterprise software. Now, this has been going on for a lot of years. In my last talk I gave, I talked about the integration of sensors into legacy machines that you can find out how your CNC mill is doing at any particular point during the process. And just, you know, that's only been a recent development that you could easily retrofit this data collection into legacy machines. And so all of this stuff is connected to the enterprise resource software, the ERP that runs the company, and helps who's ever flying that plane or essentially running that business on a day-to-day basis. They got a set of gauges, and those gauges are telling them, are we making money at this point in time? Where are my production problems that I'm anticipating? Do I have maintenance issues coming up? And so this is, you're entering manufacturing at a really very new type of environment since that I grew up in. Industrial engineers need to know that 100% inspection is not only very expensive, but it's not necessary if you use sampling techniques, process control charts. But if 100% inspection was able to be performed at essentially no cost, you'd really want to do that because you'd have a great data collection on what you produced and on a per part basis or some serialized basis. So automated inline optical inspection allows these digital manufacturing lighthouses to capture data on essentially every component that they manufacture within the four walls of the company. And so this is another example of Internet of Things enabled manufacturing quality management. Off-the-shelf sensors for every conceivable metric that you would want to measure in your manufacturing process is available today. And many of them come with either internet or wireless connections that you can directly connect to a company's intranet. A new term appeared in this company for me, and that was digitally enabled variable takt time. That's a really amazing thing to think about, because we think about takt time, it generally tends to be really static. And can I match my customer demand rate, match my production rate, you know, and it might go up and down, slowly go up and down. But this is saying that you have the ability to match the customer demand rate in real time to the manufacturing, to modulate your setup and your run times and your run quantities to coincide with the changes in the product in real time. That's just really makes, I just saw this. This term was really cool. Tool and die manufacturing can significantly be reduced using digital methods in-house or across supply chain. They didn't have a lot of detail on that. And then we have, when we're thinking about a Kanban, a Japanese word that means signal to produce. And some basic examples could be an empty box that is transferred back upstream through the manufacturing system to be filled by some upstream person or machine that's going to fill the box up. But there's other examples, like you could take masking tape and put it on the floor of your factory, say the size of a car. And if we were able to put a new Ferrari in that, if there's a Ferrari sitting in that taped in box, we don't need to make a new one. But if we have this tape box on the floor and there's no new Ferrari in there, then we need to make a new one. So the signal to produce is much more enlarged than just our traditional thinking of sending empty boxes back upstream. So this particular slide is interesting from the point of view that most when we think of RFID tags, we think about them for location and counts tracking. But you could also use them to put a pull system together, create an e-Kanban, which I think is a really fascinating idea. Another example from this very large refrigerator factory. In fact, if you go to Home Depot and you look on the nameplates on the back, a lot of refrigerators in Home Depot, they're made by this company. And so they connect from end to end with suppliers and users. It drives the product mix within the factory. And so this is kind of an advanced pull system that facilitates final configuration of refrigerators based on customers' requirements. And I really thought about that. Why do I care about my customers' requirements in a refrigerator? It's this, box, and it has a handle on it, and you open the door and close it. But maybe we need a different temperature range because it's going in a laboratory and they have to have very accurate controls for some type of a medical sample. Or maybe we have it's stainless steel on the outside versus wood paneling on the outside versus something else on the outside. And so our ability to get our lot sizes smaller and more connected to the exact customer demand allows us to more fully respond to what the customers want in real time. And I didn't really realize that that was a big deal in the refrigerator manufacturing business. Okay. So this has the idea of a manufacturing control tower, and that oversees production in real time. So when I'm thinking about this is similar to like at an airport. Everything in an airport happens in real time. There is no real inventory, right? There are planes that are coming into land and planes that are leaving. And you can't just like freeze the system. You have to respond, you respond to the system and try to manage it. But, you know, it's difficult to just kind of freeze it. And so thinking about how do they reduce rework using this manufacturing control tower idea. And so as soon as you have a defect or non-conforming product that shows itself, that you're able to insert yourself into that production system to be able to prevent any other further work be done on other parts to create more defects. And so I'd like to see that how this actually works in process, but the idea of this manufacturing control tower is kind of interesting to think about. Okay, so we have an idea that's really familiar to everybody is the idea of easily reconfigurable robotic systems. And a major cost of a new robotic system is redeploying and changing the tasks that the robot performs. It's always been traditionally very costly. And big companies could absorb that, but as robots become more distributed in small and medium manufacturing enterprises, then the ability to have robots learn on the fly, remember steps. We have a couple of these over in Washburn that we brought in for the cobots training from the ARM grant, and that you can change the task that the robot's going to do really quickly. And so digital manufacturing lighthouses overcome the setup time costs that often prevents the adoption of robotic systems in a lot of other businesses. And this last example was using a remote sensors to do machine learning, applying rolling force in an industry. They have small increments of productivity, but that small increment may actually be quite a large dollar value, because you're thinking about a rolling process. You generally don't have rolling process that is not of a small nature, and so have a big impact on the business. So an area that manufacturing engineers can have a big impact is the development of minimum viable product of the company's industrial Internet of Things operating system that can then be replicated across the company. And so you might develop a digital process in one part of the company that can be scaled up and deployed even remotely into other remote locations. And so if we take another look at the air conditioner manufacturers, sales are not considered to be a one-time event, but repeat sales will be developed from any particular customer due to these digital connections made by the interaction between the customer and the factory. And this type of interaction between producer and customer is very difficult for competitors to break into once that connection has been established, provided that you're satisfying the needs of the customer. The customer would say, well, you know, why would I ever want to change and go to another supplier? Even sometimes cost isn't even factor into it, that they're willing to pay more because the value of having guaranteed delivery in a short period of time, or the customization in a short period of time, will trump the cost of providing it. Okay, so losing my. So what do manufacturing engineers need to be able to do? Well, of the 6 things listed here, which came from McKinsey, the most important, I feel, is your ability to create transparency in a multi-tier supply chain. You need to be able to deeply understand how inventory moves through the entire supply chain, and you need to be constantly thinking about optimizing not only the production, but also the distribution methods that are used. And a clear example has been playing out in the media recently with the personal protective equipment manufacturing and distribution supply chain on a global scale. So McKinsey also produced this graphic to help illustrate how to illustrate digital scaling in manufacturing companies, and they advocate for focusing on business value, an integrated approach to corporate transformation, develop new capabilities to be used inside the company, and then multiply these newly developed capabilities developed by you and apply them and manage the effects of this digital scaling process. So manufacturing engineers tasked with a digital scaling opportunity can model their impact in 4 steps, and it may fall to the manufacturing engineer to understand what the data and information technology may be used to eventually facilitate these waves of digital transformation spearheaded by the manufacturing engineering group or department or person. So this might be the most important slide in the whole presentation. Manufacturing engineers need to understand they are the translators that identify the opportunities and facilitate the development of these opportunities on behalf of the company. And so the digital engineers and information technology people, they're really unlikely to have the deep manufacturing process knowledge that you know. And it's your responsibility to foresee how a manufacturing process can be used leveraging all these digital tools. So you essentially potentially come up with the idea and say, this is what I need to happen. And then the rest of the organization is supporting you. But they're not necessarily going to come up with these manufacturing ideas because it's just not something that they've had a lot of training on. Okay, so manufacturing engineers should be able to calculate the value retained in the company as a result of their participation in the scaling and the rollout. That's a common theme that runs through all my courses is, can you describe from an economic point of view the value of your work and what you bring to the company? Every single course I teach, grad and undergrad, has that built into it. Manufacturing engineers should be aware of and supporting and leading the digital center of excellence in their organization. You may have to be the one that creates the digital center of excellence because they haven't thought of that they needed one, but you're going to need that in this environment that you're going forward after you leave WPI. So similar to a Six Sigma black belt, where these highly skilled engineers are able to reproduce substantial financial gain through productivity improvements in multiple iterations, the manufacturing engineer can deploy digital scaling in multiple iterations across the manufacturing organization. So this slide refers to an interview from a venture capitalist who was on CNBC just the other day. And this guy was advocating that artificial intelligence and robotics and additive are going to get tremendous investment over the next few years as a result of the COVID-19 virus. So there's a few sources of peer-reviewed literature that I looked at, and this particular book, which just came out, describes in great detail how to accomplish digital scaling. And frequently, digital scaling might be called something else, like networked engineering systems or some other name. But in recent years, the ability to have digital technology infiltrate basic manufacturing processes has been never greater at any point in history. So you need to be able to recognize and imagine and synthesize for yourself in a real manufacturing environment. If you allocate time in your weekly schedule and you develop many ideas, it's going to be difficult to work on all of them. So you could meet with a group online for an hour for coffee or on a regular basis. I actually do this now. I have a group that I meet with and we talk about solving some interesting challenges that are manufacturing oriented. And we've been going at this for quite a while. So I don't know if you're familiar with this book. I know when Professor Brown teaches MFE580, I know the book comes up in the slide deck, but the book is tough to get and it's expensive to get. But I have a copy signed by Dr. Sue. And so if you've had me in the operations class, you've heard me ask, how do you become the smartest person in the room? And the answer is, my answer anyway, is by being correct about problem solving most of the time. Well, how would you do that? You need to be proficient at problem definition, because you can solve any problem, but defining the problem is usually where the big challenge is. And so how do you become proficient at problem definition? Well, you can use the axiomatic design method. So this is the table of contents that happens to be in the book, The Principles of Design. And if you look, the 9th one, this is kind of interesting. You have this design book And Nam is definitely mechanical engineer. He's designed engines and electrical systems that propel mass transit vehicles. The guy is really a hardcore engineering person, right? But here's this book called The Principles of Design, and he's talking about designing an organization which has people in it. And if you're tasked with designing a manufacturing system, you not only have to think about, okay, how many strokes per minute or how many chips are coming off, and how fast am I burning through my tooling, and various industrial engineering concepts like looking at bottlenecks and things like that. But you've got this support system of people and information that supports all these various manufacturing processes, and they're largely invisible. When you walk out into a factory floor, you don't see all the stuff that happens in the background that enables this process to take place. And so when I first studied axiomatic design, I was really intrigued by, here's this mechanical engineering professor from MIT, and he's talking about designing, designs of people organizations, which was really fascinating to me. So Nam wrote the second book, and that's called Axiomatic Design Advances and Applications. And if you take a look at this book, then the table of contents, he continues more on design of systems and design of manufacturing systems in particular. And so if you are in a graduate program or a PhD program here at WPI, the understanding the fundamental ideas in the axiomatic design method is not a trivial matter. It is one of the most, if not the most robust problem-solving method that I've ever encountered in my career. And you can apply it in a very formal sense using the Claro software out in the field someplace, or you can do it really informally. You grab a pen and a paper and draw a couple of boxes, and you don't even tell the people that you're looking at FRs and DPs. It's talk about goals and how to achieve them. But the framework of understanding how the system that you build and the way that you're fulfilling the goals, that if you have interactions between the goals and the way you're fulfilling them, potentially causes a lot of problems in your system. And so we've seen some of that. And I have an example coming in one of my last slides about the meat packing industry, which happens to be a manufacturing system. And whoever designed how the meat packing business works, they missed a couple of key FRs and the DPs that they use. And so now I've got this national problem with them potentially shutting down, right? So, what inherent risks are built into various manufacturing supply chains? And the reason I mention this is I don't think you should blindly go off and say, well, we can just go and add all kinds of this digital technology onto a manufacturing process and we can scale it up. Professor Towner said we could scale it up, or the World Economic Forum said we could scale it up. There's all these examples. And even the examples that I showed you today from World Economic Forum and McKinsey, they've got inherent risks built into these systems that are going to appear at a very inopportune time. And they may be even experiencing them currently. So I advocate for you just to do a really great job on problem solving so that we don't miss something. So much of the US meat industry, which happens to be a manufacturing system, is predicted to shut down without government intervention. And there's a quote here from this professor from University of Notre Dame that explains why that is, because meat needs to be kept cold. And you can't have a large amount of inventory in the system at any one time, because it wouldn't be fresh meat anymore. It would be either frozen meat or it would be meat that you wouldn't want to eat. And so now, the CEO of this very large pork producer out in South Dakota has been on TV every other day saying that, this manufacturing system that we run, now he doesn't use those terms because he doesn't think about that he's running a manufacturing system, but he is. And he's saying, we need to have someone change the underlying ground rules for us in order for us not to come offline. Could they have anticipated that and made other arrangements years ago? Absolutely, they could. And so that that gets to my idea of how do you become the smartest person in the room. You're very good at problem solving, and you're always really do a very excellent job at it. And why is that? Because you have considered all of the goals of the system, and the way you achieve them, you're able to address them. So I don't want to belabor that too much. So this graphic came out of that engineering architect manufacturing text that I showed you a couple of minutes ago. And so what this is talking about is as you're developing a networked engineered system, and on the left side, you see we have our system is functioning, the little ball on the top, and then we've got this process that goes along. And then as the problem shifts, you no longer have a fit. And my argument, and Nam's argument, and Chris Brown's argument is that you ought to be able to anticipate that in advance, because you did a really great job in defining the functional requirements of the system and how you're going to achieve them. And so on the left, what happens here is they're essentially building tolerance into the system. Tolerance on the FRs, maybe you have tolerances in other parts of the system. And so my question to you is, will you be able to design a digital manufacturing system that is flexible and robust and fault tolerant to accommodate for the tolerances required in digital manufacturing? And I don't think very many people are thinking about that. I think they take their Microsoft Windows product, or they take some sensor and they just marry it all together and off they go. And then they find out a year down the road that the whole system came to a halt because the definition of the faults that we're going to develop in the system, the risk in the system, were not done at the outset. And then now you got to pay the price later. And that's one of the reasons that Nam came up with this axiomatic design method, was to reduce or eliminate, but reduce non-productive iterations. That is really almost the point of this whole discussion here today, is you're going to enter into an environment where you are the translator. You're able to say, here's my manufacturing process. I think that we can put some digital tools onto it, understand it better, and we can scale it up. And I say, hooray for you. I'm really happy that you're going to do that, but you need to have fully defined the problem so that you don't find down the road that you miss something. Okay, so getting back on track to the digital scaling thing. So I hope that you're able to recognize and imagine and synthesize opportunities from your manufacturing engineering education and apply them in a real manufacturing environment. But we also want to do a good job to have elegant and robust solutions to your manufacturing system design. And one excellent way to do that is to follow the axiomatic design framework as you're designing your digital manufacturing system. And this will help prevent problems from developing, because we didn't build any tolerances in our system. And when it starts to perform in unforeseen ways, the system is robust and will continue to function, versus what is happening in many supply chains that we see across the globe today. And so this is my final slide. This is the same slide that I had from the last talk, and I kind of liked it because it had this cool graphic on the left side. And obviously, we didn't have our wonderful get together on March 26th, but so that's pretty much what I have. And one of the things you could do to help yourself is grab those publications that I put out there, the one from the World Economic Forum and the one from McKinsey, and take a look at them, because you're going on to that world, and I think you want to have a good idea about how other people see the world. So with that, let's see, I'm trying to turn my camera back on, and I don't know how to do that. All right.
Okay, yeah, thank you very much.
That's pretty much what I got. But I found a lot of the ideas were just really cool. I mean, a digitally variable tack time, right? I mean, Never really thought about that before. I mean, it makes sense in retrospect, but I've never seen that in any text or any paper anywhere. Um, but I want everyone that's listening to this to be substantially successful in your career. And sometimes that means that you have to take a step back and add a little extra upfront time on the analysis end of it, so that down the road we don't have are you going to create a giant disaster where people are going to, their lives are at risk? Not likely, but you could have your pharmaceutical production line come offline because it doesn't incorporate some variability in it. And as I know, I'm an engineer, and I always thought I knew the right answer to do everything, right? And just right down the line. And then when things didn't work out, I said, well, okay, I guess I didn't quite really understand that problem as well as I thought I did. So that's really the point of it, of what I wanted to communicate to you today. And so if you have any questions or if you want to email me.
Yeah, we already have a student here. I guess student, right? Gabrielle, is that right? I unmute you.
Hi.
Hi.
Hey, Wally.
Hi, Gabrielle.
So my question was basically with all of the, sorry about that. With all of the changes to basically how we make things, do you think there's going to be a change to what the global supply chain looks like after COVID?
Oh, I think it's already started. It's already started. So there are some things that supply chains came up short in a lot of areas that no one ever expected, right? This meat packing business, they didn't think everybody would get sick at the same day, on the same day in the whole industry and fall apart, right? So, I mean, that was pretty obvious. But you've also have some international tension taking place. And I certainly don't want to, explore that very much in this presentation. But I will say that if you look at the Wall Street Journal, you look at some of these really global publications, they're talking about countries, not just the United States, but other countries having the ability to manufacture their own medicine in their own country. Because having foreign sources of supply, it may be great, it may reduce the cost of production, but then you lose control, and then you have prioritization, who gets it and who doesn't get it. And so do I think that the supply chains are going to be reconfigured? Absolutely, in ways that we haven't even imagined yet. But part of it is just control. And I know when I owned my manufacturing company, when I gave work to another, either a sheet metal house or another machine shop to do work, I was at their mercy, and I had to wait until they took care of me. And I actually had a really important machining job go to a machine shop up the street, and they started working on it. And then in the middle of it, they stopped because their largest customer came in and said, you got to work on our stuff. And meanwhile, my customer is waiting for me, and I can't answer the question because I don't even have the raw material in-house anymore. I gave it to somebody else. So this idea about controlling your own destiny in manufacturing became really evident in what took place as a result of COVID. I live in Rhode Island, and on the front page of the Providence Journal today was that we apparently had a flood somewhere in Rhode Island last fall in November or December. And guess what that flood took out? Our personal protective equipment where the masks were stored. So they lost all of the masks that were on the bottom of the storage facility, got wiped out by the flood, and they had to throw them away. And so that wasn't foreseeable that we would need to do that. So I think that things are going to change on the supply chain? Absolutely. You have a lot of things are going to change as a result. And one of the coolest things that I saw in all of this, and you've seen it too, was the people that reconfigured their production systems to make the ventilators. Fortunately, we did not need nearly enough of ventilators that everybody thought we were going to need. But Dyson, the vacuum cleaner company in England, they put all their engineering talent on, and they developed a ventilator that they could make for like $10 or something. It was ridiculously inexpensive. And then you had people taking the CPAP machines that people have for COPD, and reconfiguring those so they could become ventilators. And then Ford Motor Company. And then, of course, the US government was pressuring General Motors to make ventilators because they made them before. So this wanting control your own self-destiny, I think, is going to be a big driver of how supply chains get reconfigured. Does that mean we're not going to go do business other parts of the world? Absolutely not. But I think that you're going to see this reconfiguration where we've got risk mitigation. And just one more thing I want to add to that. There was a young lady graduated a couple of years ago that she was a dual industrial engineer, electrical engineer, and she got hired by Lutron. And when Lutron interviewed her, they gave her this, the famous Google question. What happens if your supplier gets taken out by the Japanese nuclear reactor going down and you can't get parts out of Japan anymore? So she's 21 years old. And here's these people running this gigantic, electrical light manufacturing company that you can go to Home Depot and buy all their dimmer switches and everything. And they're asking her, what should they have done to prevent a problem in the supply chain that came out from the Fukushima disaster, right? So more and more companies and governments across the world are thinking about how these supply chains interact for risk mitigation.
Okay, that's good. And Yao, you have questions?
Yes. Hi, Professor. Thanks for the talk. I have a question about the distributed supply chain as suggested by McKinsey. So my question is, it looks, if I understand correct, the distributed supply chain is that we are like, instead of like huge, gigantic industry clusters, it's more the small manufacturing blocks, maybe more robust. But my question is that how these distributed supply chain maintain a high efficiency in manufacturing and the market, because according to Adam Smith, the division of labor or manufacturing is governed by the size of the market, but at current like globalization, like the market and the manufacturing is globalized, so we have pretty like long supply chain and centered supply chain. If we have a distributed supply chain, are we gonna have like reverse globalization? And if that is the case, what would be the driving force for this reverse globalization?
Wow, that's a pretty sophisticated question. So my perspective and what I've read is that this digital manufacturing supply chain economy paradigm is not going away, and it's going to accelerate. And the real question is your company, whether it's a two-person machine shop, because that's kind of an extreme example, but a small company versus a big company, you are either participating as a component part in that digital supply chain, or you're going to be out of business. You're going to be gone. There's not going to be a an either or. You're either going to be able to integrate your large or small organization into this broader digitally connected manufacturing world, or you're not going to be a player. And maybe someone will buy your company and then they'll absorb it into theirs. But we're not going to go backwards. So this deglobalization, what a really fascinating question. So as I mentioned a couple of minutes ago, you've got this nationalistic thing going on saying, wow, we've got to produce everything locally. And there's a lot of calls for that. Even, US leaders are saying that. Realistically, not going to happen. This is not going to happen. Everybody wants the iPhone to come back and be made in the United States. It's not going to happen. Steve Jobs told that to Obama, and I'm sure that Cook is telling that to Trump, right? I mean, it's not coming back. But what's going to happen is you're going to have, you're going to be able to mitigate the risk in the system because you either have duplications of the system like digital twins, but in the manufacturing sense, maybe some critical components will go to certain countries because they think strategically they can't let go of that. But I don't see this wholesale walk away from the whole system. It's all about risk mitigation, right? I mean, that's really what it is. And so I think that the interconnectedness of this global digital manufacturing community that's what's going to happen. So no, I don't think it's even possible to have it deglobalized, but people are going to look at where do the risks get introduced into the system so that we can address them, right? That probably makes sense, right?
Yeah, thank you.
Okay, that's great. Any other student have questions? If you do, please just raise your hand. So what I have a question for you. So I'm a fan of Tesla, right? So you show a slide on that, and you show several companies. So how does where does Tesla actually stand in this digital manufacturing? Yeah, I mean in the whole world.
Where does Tesla stand, or?
Yeah, the company, right? So they are pushing this very hard.
So the one thing that Tesla has going for it is Elon Musk, right? The guy, he's an independent thinker. We had some students, one in particular, that went out to work at Tesla and on an internship and came back, and they had hired a robot company to come in and put some robots on the assembly line, and the robot company told Elon, we can't put the robots there because it's illegal, because they could hurt workers and OSHA's not going to like it. And Elon said, well, you need to screw the robots to the roof. Okay, problem solved, right? This guy is an independent thinker. And so he's got manufacturing, I think, starting in China, right? And you also have manufacturing in California. I think they're gonna lead the way, right? I mean, very much in the Steve Jobs model of the world, that you've got this dynamic force for innovation and how special that they are. No, I think that, and of course we learned from the 1970s and 1980s, 1990s, you can't sell cars in any particular country unless you have some kind of a manufacturing footprint there, because the government is going to put taxes on your cars and you won't be able to sell them. So Toyota comes over and they make cars, and Mercedes is making cars in Louisiana. Who would ever think that, right? Ford has global manufacturing. So, you're going to have plants all over the world, and how they're connected and how they share the intellectual property, that remains to be seen. But, I think right now we're in this, everybody's reacting with this knee-jerk reaction. And let's talk to Dr. Su, right? Dr. Nam would say, what are the FRs, right? What are the functional requirements? And you can't solve all those FRs if you're just going to pull all that manufacturing into your own country, not just us, right? It could be Germany. China could pull their stuff back too, right? I mean, they have some impact on this too. So no, I don't. I think that I think companies that like Tesla are going to actually lead the way, frankly.
Okay, that's good. All right, okay. I guess that's it for today, right? Unless any other students still have questions. So thank you very much to give us this, great talk. I really enjoy this. Okay, so for the students, I see most of the students have already taken the poll. So that will count as the attendance. And I will send everyone the recorded video in the Canvas as usual. And also I will send you this live streaming YouTube link. All right, okay, I guess that's it for today. Thanks for everyone. All right, okay. Thank you, bye-bye.